So following on from the previous video, I gave you this problem to solve. I asked you to find out the limit of this whole thing here as x approaches positive 3. And we used one of the 6 laws to solve this here. And by the way, to get from here to here, you see this bit here, I actually use this law here to get me from here to here. That's why you've got a 5 here, and then the limit goes on the other side. Well, to get from here to here, I actually use this law here. Okay. So anyway, I've explained all this in the previous video, and it turns out that the limit approaches 16 over 17, meaning that when you plot that function, when x approaches 3, which is here, because 2's here, 4's here, so 3's dead in the middle. Well, this bit here, we worked out it turns out to be 16 over 7. Okay, and then I also said that, well, if you try and find out the limit as x approaches this point here, you see there's an asymptote here. And well, looking at this function here, so this was our original function right at the start. It was this function here. When you plot y equals this function here, it looks like this graph here. Okay, it looks like this graph here. But then I said that along here there's an asymptote here. By looking at this here, looking at this here, you know there's something weird happens when this bubble here equals 0. You see, when does this bubble here equal 0? It equals 0. Hang on, this bubble here equals 0. Is when well, add 2 to both sides. So x squared equals 2, and if you square root both sides, you will get 2 solutions: the positive version and the negative version of root 2. So looking at this function here, something weird happens when x equals root 2, positive root 2 or negative root 2. You see, when you plot this, you know something weird happens along here. There's an asymptote there, but as it turns out, at this point here is root 2. Okay, so now I'm saying let's try and find out the limit of this function here as x approaches root 2. So that's around here. So let's try and find out the limit as x approaches root 2. So this was our original function here. Now we are trying to find out the limit as x approaches root 2. Okay, so well, if you put root 2 into here, this whole thing would be 0. So you can't have something over 0. So let's follow use the laws, the 6 laws that I gave you before, and try and work out the limit as x approaches root 2. So from here, visualize it as a bubble here and a bubble here. Finding out the limit of this is the same as you just finding out the limit of this thing, and on a separate occasion find out the limit of this thing, and then get the answer divided. Well, from here you can get to here by using one of the 6 laws. Okay, and then well, just follow it through. When you are here, you can actually break it up, find out the limit of this, take away the limit of this, add it to the limit of this. So that becomes this. That then becomes this here. Okay, and then well, just follow it through. As x approaches root 2, so when this thing here approaches root 2, you pretty much put the root 2 into this. So it's like this. Okay, and then take away 5 times. Well, if you put root 2 into here, it would be this, and blah blah blah. So this bit here is this bit here, and this bit here is this bit here. So just follow it through, and then, oh yeah, this bit here, you can imagine it as being root 2 times root 2 times root 2. You see, merge these two together, it will be positive 2 times root 2. Okay, so this thing here will become 2 times root 2. Okay, so this bit here is this bit here, and then what? And then just carry it through. Everything gets, well, this bit here, when you square root 2, it's going to become 2. Okay, hang on. So this one here, it will then become this. Here, this bit here, you can imagine this as being 2 times root 2, and then you take away 5 times root 2. Root 2, well, you can factor out. Well, you can factor out the root 2. So you could, well, from here you factor out. So it's like this: 2 minus 5, and then, well, you times root 2. So, well, from here you can factor it out. So it looks like this, and then this bubble here becomes -3. So that's why you've got -3, because this is positive. I'll put it in front. Well, blah 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 blah. This whole thing here becomes this thing here. Okay, so now here's a cunning bit. You then will get to this stage here. Now I haven't taught you this law yet, but whenever you this thing here, whenever there's a limit, there's a definite limit here, because this thing here I know is not a 4. This thing here is a number other than 4. So I know that this limit here is a number other than 0. So whenever this law here I haven't shown you yet, but what it's saying is that whenever there's a limit that exists here, and it's not 0, and this bit here, the limit of this here is 0. So whenever you have a limit other than 0 here, and then you have a 0 at the bottom here, then the whole limit does not exist. Okay, I haven't shown you this law yet, so you just have to take my word for it for the time being. It's a very clever law, in that whenever this here is, whenever the limit here exists other than 0, and this happens to be 0, then you can say that the limit here does not exist. So in this case here, going back to our graph here, you can see that the limit here does not exist. Okay, and also you should have another asymptote somewhere along here, and then if you try and evaluate the limit as x approaches -√2 here, then you should have another does not exist, because from the left hand side you are heading towards positive infinity, and from the right hand side here you're heading towards negative infinity. So if you try and evaluate the limit at -√2, it should not exist. Okay, but the important part of this video is that whenever you whenever you get this bit to be anything other than, whenever the limit here is a number other than 0, and this happens to be 0, then you can say that the limit does not exist. This law here is very clever. But I will elaborate more on it at a later time. Okay.